Hey there, Algebra 2. We're going to deal with complete the square right now. Um, and we found ourselves, we can use the quadratic formula. That works for everything. And when we factor, that's going to be really nice and quick, but it doesn't work for everything. Not every problem we run into is factorable. So far, what we did is we threw it into Desmos and we found the x-intercepts, right? Because that's what we're finding is x-intercepts. So we have this one thing that's kind of in between here. And we have a couple things to step into it. So we're going to look for today is we're talking about ax squared plus bx plus c equals 0. And what we're looking for is when a is 1. So when do we do this? When a is 1 and when b is even. Now I'm going to take you through and show you how you can use this all the time. So if you're like, I don't like the quadratic formula because I always have to sing that song in my head and stuff, that's fine. But why do I do it? Because especially if I have these two situations, it's going to be a bit faster, right? And we talk all the time about we have to solve these problems. It's part of what we're doing here in Algebra 2. And what I want to do is make sure I can solve it the most efficient way I can, whether that's for a standardized test or I just want to get this over with. You know what I mean? All right. So first thing we're going to do is we're going to review how to solve using square roots. So I might subtract 10 here. So 4x squared equals 36. I'm going to divide by 4, right? Because I'm trying to get this x squared by itself. I want something squared by itself. And then I take the square root. And then you're like, oh, you know what? That's plus or minus 3. Okay, so as we solve here, we're going to work with that. So if I had positive 3 and I squared it, this would work. If I had negative 3 and I squared it, this would work. Now, what I'm going to also do is add 5 over here. 3x squared equals 30. I almost wrote 10 already. Divide by 3 because I saw that was going to happen. Then we take the square root. You know, like x equals plus or minus the square root of 10, right? I could break it down into 2 and 5. That doesn't fix anything, so that's what we're going to leave. So we can get those radical answers. No decimals. No decimals, what we're going on today. All right, so what we're going to do is we're going to try and figure out perfect square trinomials. Remember, we dealt with this before. That means you have a trinomial, and this happens to be one of them right here, right? Because I have a perfect square and a perfect square. So if I do x plus 2 and I squared, right? X times 2 gives me 4x. So this is a perfect square trinomial. And what that means is I can write it this way. And now that I have a square by itself, right, just like we did up here, all right, don't move, don't, there you are. Once the square is there, to get rid of the square, we're going to take the square root. All right, so now I have x plus 2, right, because the square root and the square cancel each other out, and this is plus or minus 5. That's probably the only real change is we do have to consider the negative part of this now. So negative 2, negative 2. All right, so here's what I have. X equals negative 2 plus 5, and x equals negative 2 minus 5. So I'm going to get 3 and negative 7 as my two solutions to this whole thing right here. All right. So here's what's happening is this one, we gave you a perfect square trinomial, but the trick is you can make them. What? Yeah, they're like the little Keebler elves. They make those cookies, eat all you want, stuff like that. I think that might be from Doritos or Cheetos. All right, sorry. But here's what we're going to do. So this says you have a b value. You're going to take half a b and square it, and that gives you a binomial squared. In other words, a perfect square trinomial. Okay, so that means if I take 2, right, so I'm going to take half of 2 gives me 1, and 1 squared gives me 1. So 1 goes here. What's that equal to? X plus 1 squared. Okay, so we'll go here. A is 1, B is even. So what I have to do is take half of 10. So that's 5 squared is 25. So 25 goes in the blank. And what happens here is I need x plus 5 squared. So once you take half of it, right, the number that you square is the number that's going to go, that 5, that's what's going to go in the binomial. Okay, so I'm going to do a few more here with you. Let me try and zoom in. Okay, so we're going to have here. So here, honestly, this is how you're going to do it. You're going to say negative 4. So half of that is negative 2. Negative 2 squared is 4. Okay, so we're going to work to the binomial first. Okay, I'm tired of trying to follow the book. It doesn't make any sense. Well, it makes sense, but I think there's a better way. Okay, so half of 100 is 50. Okay, so now we need 50 squared. Okay, so that's 2,500 goes right here. Okay, so you're going to set this up. We got x plus half of 12 is 6, squared is 36. Okay, so x minus half of 32 is 16. 16 squared, 256. Let me just double check here. Yeah, 256. All right, I'm with it here this morning. All right, so that's the process we're going to do. All right, you ready? All right, so we're going to take half of b. Half of b goes in here. We're going to square it, put it back there. Cool? All right. Now, there's one thing we said in the way beginning is we said a has to be 1. If it's not 1, like this isn't a suggestion. This is a must. So what we'll do is all this is divided by 3. So I have x squared minus 4x plus 2 equals 0. Okay. X squared minus 4x plus blank equals negative 2 plus blank. All right, so what it did is I subtracted the 2, because when I do this by complete the square, I want the x squared and the x term on one side, everything else on the other. So it breaks the pattern. Everything else we were doing, we wanted to have it equal to 0. This one, not so much. All right, so here's what we're going to do. Negative 4, I want half of this is negative 2. Negative 2 squared is 4. And if I add 4 to one side, guess what? I got to add 4 to the other side. There it goes. So we've now made it into a perfect square trinomial and factored it all at the same time. Reduce this side. Negative 2 plus 4 is 2. Take the square root of both sides. So x minus 2 equals plus or minus the square root of 2. And we just have to add this 2 over. Okay, so it might seem strange, but I'm going to put this green 2 first. 2 plus or minus the square root of 2. And that's all we have to do. Now, obviously, if this were the square root of 12 or square root of 24, we'd have to break it down. If it's square root of 25, we'd actually get the numbers like we did way up before all this. Okay. So that's how we're going to use it. All right, let's see. Let's move some things around here. Now, keep in mind, I want to subtract x, and I want to subtract 3 because I want x squared minus 2x equals 6. All right, this isn't going to work, right? Because a is 2, so it's divided all by 2. Plus blank equals 3 plus blank. All right, now this doesn't fit something we want to do. So my recommendation would be on any other time is I would have you do this by the quadratic formula because, hey, it's not factorable, right? We won't have factors of 3 that subtract when I move it over to give you 1. You know, factors of 3 are 1 and 3. It's going to give you 2 every time. And we have an odd number right here, so I normally wouldn't do this, but I just want to show you because I know someone, one person, that's all it takes. One person is really going to like this. And they're like, I want to use this all the time. So here we go. X minus 1/2 squared. 1/2 squared is 1/4. So that's 1/4. So that's 3 and 1/4. Now I'm going to have a hard time taking the square root of that. So I'm going to go ahead and do equals one more time and make it 4 times 3 is 12 plus 1, 13/4. All right, so those are all the same. Now I'm going to do the square root. I'm going to ignore the 1 in the middle. So I get x minus 1/2 equals, and over here I'm going to end up with square root of 13. I'm not messing with that at all. But on the bottom, the square root of 4 is 2, so do plus or minus. One more step, we need to add 1/2. Okay, so I have 1/2 plus or minus the square root of 13 over 2. And that will give me my 2 x values, right? So one thing you might see is 1 plus the square root of 13 over 2 and 1 minus the square root of 13 over 2 as you look at SAT options. Okay, trying to take the complex fraction, the 2 parts, and make it into one big one. All right, so that's our process for complete the square. Now, there's one thing we're going to do here soon is we're going to change them from vertex form to standard form and back and forth. So I just want to show you how we can do that. Okay, so what we're going to do is work with this thing right here. And again, A is 1 and B is even. So we're okay with doing this process right now. So what we're going to do is try and take this x squared plus 4x plus blank, right? Minus 6 plus blank. All right, and it equals y. So this is normally what happens. So we're going to take this whole thing here. We're going to say, all right, this would be x plus 2, right? Half of 4 squared is 4. Now, the difference is I'm on the same side of the equal sign. So if I add 4, I also have to subtract 4. So that means that we get minus 10 equals y. And when we start looking at vertex form, this is going to give us a vertex of -2, -10, because the inside is opposite and the outside is true. So that's one way we can work with that. The other question that we had here is a y-intercept. Remember, that's when x equals 0, and that one we want when it's in standard form, and that's going to give you that c value. So 0 gives you -6. So this one I'm not overly concerned with just yet if you're in my class, because I'll show you how to work through that. We'll probably put it in class and review. Okay, otherwise we have a few here we can try. All right, now, like I said, when a is 1 and b is even, is when we're going to use this. Otherwise, you can use quadratic formula. I'll be quite honest with you. I'm not going to make you use it any other time, so I don't want to spend too much time on it. All right, but that should get us ready to go. All right, peace.